Hello, this is Algebra Regents for both of Mr. Kenzie's classes as well as Mr. Erie. This is day 3. We will be talking about the relationships between two numerical variables. Your homework will be to finish any of the questions that we did not complete within this packet or within this specific day. So scatter plot can be used to investigate whether or not there is a relationship between two numerical variables. A relationship between two numerical variables can be described as linear or nonlinear. Nonlinear could be a quadratic and exponential. The example I want to look at right now says the National Climate Data Center collects data on weather conditions at various locations. They classify each day as clear, partly cloudy, or cloudy. So we have our x variable is elevation above sea level for various cities. And we also have the mean number of clear days. So these have been plotted for us. Now there are a couple that we need to plot on our own. It says most of the data points have been plotted for you already on the scatter plot, but missing data points for Raleigh, North Carolina, Salt Lake City, Utah, and Spokane, Washington. So Raleigh, North Carolina. All right, so we have, and these are going to be approximates, so we don't have a grid, but it'll be 434, so that'll be somewhere before or halfway in between 1,000, and up to 111. So about there. We then also have Salt Lake City, Utah, which have 4,221, about a quarter of the way here, and up to 125. So about there. Spokane, Washington, so 2,356, up to 86. So about there. So now, those are our data points. It says, do you see a pattern in the scatter plot? Does it look like the data points are scattered? It looks like as sea level is increasing, the mean number of clear days is also increasing. So what I would say for this is this would be a weak, positive, linear relationship. Number 2, how would you describe the relationship between elevation and the number of clear days for these 14 cities? We just said this prior. I would say as elevation increases, the number of clear days slightly increases as well. Number 3, do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and elevation? Draw the line of best fit. I would say yes, the relationship would not be exact. If it was exact, you would have perfect points on one line, but would have a positive linear trend. So our line of best fit, also known as a least squares regressions line, is a line that summarizes the points. It goes through about the same number, has about the same number of points on the top and the bottom. I would say line like this could summarize that data. So they're around that point showing a positive trend. All right, take a look at the next page, please. This is thinking about linear relationships. If one of these scatter plots represents the relationship between height and weight of 8 adults, which scatter plot do you think it is and why? So we have these descriptions and these plots. All right. So we're talking about weight and height for adults. Well, for adults, generally, and this isn't always, but as height increases, so does weight. So we're looking for a positive relationship. I would say that choice 1 would be. And that's because as height is increasing, weight is also increasing. Now, obviously, it's not a perfect relationship because otherwise it would be a straight line, and a scatter plot will not always have a perfect straight line for a relationship. Number 5, if one of the scatter plots represents a relationship between height and SAT math score for 8 high school seniors, which scatter plot do you think it is and why? So once again, relationship between height and SAT math score. And now they can repeat. I don't think height has anything to do with SAT scores, so it's not going to be increasing. This one looks like it's decreasing. I don't think that has anything to do with it. I would say scatter plot 3, and that's because the data points, there's no pattern, and it's scattered. Number 6, if one of these scatter plots represents the relationship between the weight of a car and fuel efficiency for 8 cars, which scatter plot do you think it is and why? So we're talking about automobiles. The larger the car, generally the least eco-friendly it is, meaning you need more gasoline to run it, like a F-150 would take a lot of gas, and you'd be filling your tank up pretty frequently because of use. Whereas if you had a smaller car like a sedan or a Honda, you may be able to get more mileage out of the same amount of gas. So what this is saying, I'm going to go with choice 2. The bigger the car, the worse the fuel efficiency. So the heavier the car, the worse the fuel efficiency. So the larger car, the worse the fuel efficiency. And number 7, which of these scatter plots does not appear to represent a linear relationship? Explain the reasoning behind it. It would be choice 3. Once again, there's no pattern, it's scattered. All right. Please take a look at the next page. Now, not every relationship is linear. When a straight line provides a reasonable summary of the relationship between 2 numerical variables, we say the 2 variables are linearly related, or that there is a linear relationship between the 2 variables. Looking at 8. Is there a relationship between the number of cell phone calls and age, or does it look like the data points are scattered? If there is a relationship, does it appear to be linear? So I'm looking at this. All right, it doesn't look too scattered. It looks like there is a relationship. I would say, and you think about it, I think the younger the students are, the more they're on their phone, the more they're using it, regardless if that's for calls or texts, just forms of communication. So I think as the younger the people are, the more they use their phone, and as they get older, the less it would be. All right, so this is not scattered. And I would say yes, there is a negative linear relationship. Question 9. Is there a relationship between moisture content and frying time, or do the data points look scattered? If there is a relationship, does it appear to be linear? Well, I would, looking at this, it kind of decreases in like an arc form. Now, one of the graphs that we worked with was exponential. So I would say there is a relationship because it does form a shape, but I wouldn't say it's linear. So I would say yes, but it is exponential. And in this case, it would be exponential decay. Exponential curves look like that. That would be growth. That would be decay. Number 10, scatter plot 3 shows data for the prices of bike helmets and the quality ratings of them. Is there a relationship between quality rating and price, or are the data points scattered? If there is a relationship, does it appear to be linear? Well, these data points look pretty scattered. All right, I think you can get a nice bike helmet from a variety of places, and I think the more of a name brand, the more you're going to end up paying. So I would say these are pretty scattered. You may say there's a slight positive relationship, but with this data here, I would say it's mainly scattered, and there's no relationship. Within statistics, there are arguments for both ways to discuss a point and obviously argue against it. All right, please take a look at the next page. Linear, quadratic, and exponential functions are common models that can be used to describe the relationship between variables. This one looks like a quadratic or a parabola. These ones, as we just talked about, look like exponential, growth or decay. Please take a look at the next page. What you will be doing for your homework is identifying these 5 scatter plots and the type that goes along with them. Thank you.